In this video, we are going to go over some calculations to answer questions such as abnormal returns, equilibrium, arbitrage opportunities, and so on. This should serve you also as a review or practice exercises for the exam and the midterm exam. Now here, we're only going to be calculating the things that we discussed towards the end of the course, and also related to somewhat related to what you see on the spreadsheets throughout the weeks we have been going through the different chapters. Now, before I start, this exercise was designed to have one long exercise that all related together, so you can see the relationship between these items and how they're all pretty much related, are in the same universe, to say it that way. However, in the exam, you will not have to do the entire process that you will see here. I'll explain as we go, but for example, you may be asked to calculate covariance only, done. You may be asked to calculate the Treynor ratio, done. Or if you have to answer a question about equilibrium, you calculate the Treynor ratio only, and you answer your question based on it. I will go over this again as we go, but do understand that while these calculations were done all in one long process, you will not see a question like this where you have to answer multiple things. No, it'll be one of these questions within a multiple choice situation, and you answer that one and you move on to the next one, which will only require one of these pieces of calculations, not all of them. So do understand that this was longer and a little tougher to answer if you were doing them. So if you get through this and you understand what we do here, the ones in the exam would be lighter in the sense that will be just like one item at a time, and you will have the necessary numbers to calculate that item. You don't have to start from scratch, to put it that way, and work your way down. So let's go ahead and get to it. Okay, so these numbers here are the given data, the given information. So you're not calculating this, these are just given. The correlations are also given in this case. So from here to here, data provided. Calculations start down here. Okay. All right. So you were given the price on period 0. If there was a dividend, price on period 1, and the standard deviation of these items. This is the Treasury Bill. It does not have a standard deviation because that's a risk-free rate item it's a federal Treasury Bill, so no standard deviation, no risk. They don't pay dividends in this case. It's just a face value at the end, or at the price you can sell it, let me put it that way, and the price you bought it. All right, so the way to read the correlation table is asset Y, could be a stock, but let's call it asset Y, the correlation between X and Y. The correlation between X and the S&P 500, 0.9. The correlation between the S&P 500 and Y, 0.65. Now, the reason these other ones are blank is because if you do correlation of Y and Y, it would be 1. If you were to do correlation of X with X, it will be 1. Just 1. If you do correlation of S&P 500 with S&P 500, 1. So the correlation of the asset with it itself, it's 1, because it's the same asset moving the same direction. But we just don't write it because it's understood that that's always the case. All right, so if we want to calculate covariance, we're not going to be doing the lengthy process of covariance, plus we don't have the data for it. However, because we have the standard deviation and the correlations, we can check the covariance. Now, unlike correlation, covariance would not be a fixed number if you do the same asset. I'm going to start with Y and X because it's more intuitive, it makes more sense, and then I'll go through all of them the way they are. So I want the covariance of Y with X. Let me do it here. We take the standard, the correlation of Y and X, which is 0.3, times the standard deviation of X, asset X times the standard deviation of asset Y. So it's pretty much the standard deviation of asset 1 and asset 2 with a correlation between them. You're multiplying those three together. The standard deviations of the assets multiplied by the correlation gives you the covariance. Now, the same way you can get the covariance if you have correlation standard deviation, you could, and I'm just going to do here on the side, get correlation if you have these other items. So if I wanted to find the correlation, I can take the covariance, for example, and divide it by the multiplication of the standard deviations. And if I do it right, I should get 0.3. And there it is. What I'm trying to get to is the same formula. If you turn it around to solve for the one you're missing, works in all cases. So if you have covariance, correlation, and one standard deviation, you can get the standard deviation of the other one. Anyways, you can, once you have only one missing piece between these, you can find the one that's missing. But here we're looking for covariance. Okay, so let's say I want the covariance of the S&P 500 with asset X. Same process. The correlation of the S&P 500 with X multiplied by the standard deviation of this asset multiplied by the standard deviation of the other asset, S&P 500 and X. You multiply those three, you get covariance. Now let's talk about the covariance with the same asset. So let's use Y, for example. I like to use Y for this example. You're going to notice that here, we only pretty much squared the standard deviation. We're doing the same thing we did before. For example, when I was doing this one, we did correlation times standard deviation times standard deviation. If I was to do the whole thing, remember earlier when I said the correlation of Y and Y equals 1? If I was to do, I'm going to here on the side. I was going to follow the same process. It's the correlation times the standard deviation of the first asset, Y, times the standard deviation of the second asset, Y again, because it's the covariance of Y with Y. And that's why you get that number. However, because this is 1, I really don't need to write it. I need to include it. Because if I take the standard deviation times the standard deviation times 1, it's the same as the standard deviation squared. Or in this case, because it's the same letter. So that's why it looks a little different. And it's just because we are skipping the correlation because it would be 1 when you have the same asset. Okay. So once we get to the expected return section, these calculations down here, this is the same as your new minus old divided by old. I just do a little different. I do new divided by old minus 1, but it gives you the same number. However, the little extra here is that this here, C5 plus C4, is because we need to take the future price, the new price, plus any dividends paid. I know it's 0 in this case, so it doesn't make a difference, but that's the formula. You have to include dividends in case they do pay dividends in the future, or like asset Y, pay dividends. So what we're doing is the selling price, the new price, plus dividends divided by the old price minus 1. That's the same as the other version, you know, of new minus old divided by old. So you just calculate that and you do the same for Y. And the same for the S&P 500, and that is your expected return. You can also apply it for the T-bill. In this case, there is no dividends, but same thing. Dividend don't apply on bonds, only on stocks. But you'll get the right result, which is 2% in this case. Now, beta, there's a lot of ways to calculate it. The way we're going to follow for this is the S&P 500 covariance with X. Remember, that's the X. So we're looking for the beta of X. I should have said that first. Beta of X. So you take the covariance of the S&P 500 with X and you divide it by the variance of the S&P 500. Now, notice I said variance, not standard deviation. That's why in here, you see the formula has G6 squared because it's divided by the variance of the S&P 500. I'll repeat. I want the beta of X. So I'm going to use the covariance of X with S&P 500 divided by the variance of the S&P 500, which is the same as saying standard deviation squared. Keep that in mind when it's the difference in variance and standard deviation. You get a beta of 115, same thing here. And here you apply the same formula, but we all know that the beta of the market, it's 1. CAPM, the same CAPM you have always done. Risk-free rate plus beta times the market premium, which the market premium is this minus this. I'll repeat. CAPM, risk-free rate plus beta times the market premium. You do that for all of these, and that's your required return. For this side of finance, to put it that way, it is important to make the distinction between expected returns and required returns. This is what you require to get based on the risk you are taking. This is what's expected to be returned based on the expectations of the stock price and dividends. I'll revisit it back here, but remember, required versus expected. What you must get, what you should get, or what you want to get versus what it's looking like that you're going to get. Now let's go ahead and we'll revisit this and how we use it to answer those questions. Let's calculate the Sharpe ratio. Sharpe ratio, you already know the formula, is the expected return minus the risk-free rate divided by the standard deviation. Same thing with all these, and that's a Sharpe ratio for X, Sharpe ratio for Y, and the Sharpe ratio for the S&P 500. Trainer ratio, by now you should know that is almost the same as Sharpe ratio, except that instead of dividing by standard deviation, you are dividing by beta. That's your trainer ratio. Jensen Alpha, as discussed before, it's pretty much you calculate CAPM, but you're going to subtract. CAPM is already calculated here, by the way. So it's going to be the expected return minus the CAPM. And that will give you the Jensen Alpha. Repeat that one again. Since you already calculated CAPM, all you have to do is expected return minus CAPM, the required return. Expected return minus required return. Now, here's where we're going to start talking about how to analyze or utilize these numbers. So is it overpriced? Is it underpriced? Or is it properly priced according to the market conditions? Now, I do have an if statement in there, but that's just so when I change the numbers for different different practical exercises and do different numbers for it, it updates automatically. But what you need to know is if the expected return is less than the CAPM, it's overpriced, meaning that the price has to come down in order to meet the required return. Another way that you can look at it is if your Jensen Alpha is negative, then you're looking at an overpriced stock. The price will come down in order to meet the required return based on the risk. Now, that's assuming the risk stays the same. If the risk was to change, that's different. Then it could adjust. But since risk is not something you can change immediately, it's very difficult. It's the market will adjust price a lot faster than the company can, then the stock can adjust their risk. Same here. So if I look at the expected return is 20% and change versus the required 10, it's clearly returning a lot more than the required. So we're going to call that underpriced, meaning that that stock is going to go up in price because it's returning, or it's expected to return a lot more than the requirement based on the risk profile. In this case, this is the market. So we're going to say it's properly priced because it's expected to return 10%. The required return is 10%. So the Jensen Alpha is 0. So we're going to call that properly priced. Now, the common practice is if something is overpriced, you want to short that stock because it's going to go, if you want to trade, it's going to go down in price if this pattern continues. If it's underpriced, you want to buy it because it means the price will go up. And it makes sense. If it's expected to return a lot more than that's required, people are going to buy it. Now, if it's properly priced, we're going to, for this class, this course, we're going to say it's a hold. It could be a buy in some circumstances, definitely not a short, but we're going to say it's properly priced and just hold it. Not necessarily to buy more, it's just performing as it's supposed to. But depending on your strategy, you may see that when something's properly priced, it might still be a buy. But that has to do with your overall strategy. But for here, we're going to say overprice you short, underprice you buy, properly you hold. All right. Now let's talk about these questions here and with this information we have here. Consider the data table above. They meaning this here, this data here. Would you buy or short stock X and Y? So the answer is to short it, but we already answered that over here. You want to short it. And the reason is because it's overpriced. Why is it overpriced? The expected return is less than the required return. Now, you are not going to have to write these answers like that on the exam. You just have multiple choice questions, and you have to pick the one that expresses that. Would you buy or short stock Y and Y? The answer is you buy it. For what we said is underpriced, so you buy it. Why is it underpriced? Jensen Alpha is positive, or you can say this is much higher than that. We already went through that in that sense. Okay. Which stock has abnormal returns? Well, the answer is stock X and stock Y, but not the market. And this has to do here strictly with Jensen Alpha. Abnormal returns just means that it's off the required. It doesn't have to be positive. This is just an abnormal loss, if you want to call it that way, because returns can be negative, meaning a loss. And this has an abnormal return, the positive, but they're both abnormal because they're off the mark. It's not 0. When it's 0, then there's no abnormal returns. Are stock X and stock Y in equilibrium? The answer is no. How do we know? You compare the trainer ratios. If they are different, they're not in equilibrium. It's as simple as that. Look at the trainer ratio. If they're not the same, which they're not, and for that matter, none of them are in equilibrium. They're all different. But typically you compare 2 at a time, at least for this class. That's all you do. Get the trainer ratio. If they're not the same, they're not in equilibrium. Which stock is in equilibrium with the market? The answer is none. And that's what I just mentioned. Nobody has the same trainer ratio in the market. So not only they're not in equilibrium with the market, but they're not in equilibrium with each other. So they're just way off. Are there arbitrage opportunities? Well, the answer is yes. And this is why. If they are not in equilibrium, if there's anything that is not in equilibrium, then yes, there are arbitrage opportunities. Again, you just look at a trainer ratio. As long as you have 2 of them that are not the same, any 2, doesn't matter, there is an opportunity for arbitrage. So now, if there are arbitrage opportunities, what are they? You're still going to work with a trainer ratio, and this is how it works. One opportunity is you can short stock X and long stock Y. Put a long position on Y and do a short position on X. How do we decide that? It's very easy. If we're looking at X and Y, they're not the same. So that's the opportunity we talked about, right? The one with the higher trainer ratio is the one you will take the long position. The one with the lower trainer ratio between the 2 is the one you'll do the short. And that's all you do. Another pair, X with S&P. So if we do the trainer ratio of X with the trainer ratio of S&P. Again, X is smaller than S&P 500, the trainer ratio. So the larger one gets long and the smaller one gets short. And that's why we wrote here short stock X, long the S&P 500. Same rule. Now, if you do the S&P 500 and Y, it turns because Y has a larger or greater trainer ratio than the S&P. So you long Y, short the S&P. That's what you see here, short the S&P 500, long stock Y. So all these were answered basically by looking at the trainer ratio. If they're different, they're not in equilibrium. Can you arbitrage? Yes, because they're not in equilibrium. How do you take advantage? Look at the larger trainer ratio, the greater trainer ratio. That's the one you long. And then you pair it with another one, and that is shorter, and that's when you short. And that's how you answer that. That's all you do. Trainer ratio works for the equilibrium and arbitrage and the strategy. Let's look at question number 2 here. Now, these are somewhat related, but you don't necessarily have to know the numbers, but you need to know those patterns and behaviors that we just talked about. So let's say we have stock ABC and stock DEF. Have same positive expected returns, but different betas. So the question, are there in equilibrium? Again, we use the trainer ratio to do that, but we don't have numbers, but that's okay. The 3 numbers we need for the trainer ratio is expected return, the risk-free rate, and the beta. Now, if the risk-free rate is the same for both because it's separate, so that number is going to be the same. The exercise is telling you you have the same expected returns. So the numerator of the trainer ratio will be the same. Regardless of what the numbers are, we know that in both calculations, the numerator, the number top of the line, is the same for both because they have the same expected returns and the risk-free rate will be the same for both of them. However, they have different betas. So you will get 2 different trainer ratios. We don't need the numbers. The fact that we know that we're going to get a different trainer ratio means that they're not in equilibrium. The only way you're in equilibrium, the trainer ratio is the same. So again, the numerator is the same because expected returns are the same and the risk-free rate will be the same regardless of what it is. But they have different betas. That's going to trigger a difference in the trainer ratios. So no, they're not equilibrium. So is there an arbitrage opportunity? The answer is yes, automatically. If you're not in equilibrium, the answer is yes. So far, we're able to answer these 2 questions without having to calculate anything. We just need to know the formula and how it works and what we're looking for. So this is more of a logic thing. Having different betas will lead to different trainer ratios if you have the same numerator, expected returns and risk-free rate. If there's an arbitrage opportunity, what should you do? Well, similar to how we answered here, but because we don't know which one's going to be greater, we can tell that a higher beta will lead to a lower trainer ratio. And the lower beta, because it's in the denominator, will lead to a higher trainer ratio. So all we need to know based on this information is the one with a higher beta, you want to short that one because that's the one that is going to give you a lower trainer ratio. And then the one with a lower beta, you want to long that one because that one lead, a smaller denominator gives you a higher number after you divide. So this is a logic situation. Portfolio. Now, question number 3. If we have a situation where portfolio A is a 2-stock portfolio and portfolio B is also a 2-stock portfolio, they could be the same stocks, they could be different stocks. And actually for this exercise, at least one stock has to be different. At least one stock has to be different for the purpose of this question. So both portfolios have the same expected returns. Okay, so again, we have an equality thing that regardless of the stocks in there, at least one stock is different from the other portfolio, but they still have the same expected returns. So they have that similarity. The question is, which one has the lower standard deviation? This is a question about diversification. This is a question about diversification. and efficiency, the efficient frontier. Now, we do know, or we have learned in the last few weeks, that the lower the correlation, when you combine the stocks, you can achieve a lower standard deviation, a lower risk. That's the whole point of the efficient frontier. So correlation goes from -1 to +1 and everything in between. So the lowest you can achieve is -1, and the highest correlation possible is 1. If you have a correlation between assets of -1, you can calculate the proper weights and reach 0 standard deviation. Now, good luck ever finding 2 assets or more that have a -1 correlation. But the point is that the math says that, it checks out that a -1 correlation, the lowest correlation possible, you can combine stocks to where you have 0 standard deviation, the lowest standard deviation you can achieve. But it doesn't matter if you have a -1 or not. You don't need to know it. All you need to know is that when you compare both portfolios, if they have the same expected return, check the correlation of the 2 stocks in portfolio A and the correlation of the 2 stocks in portfolio B. Whichever portfolio has the lower correlation, that portfolio will have a lower standard deviation. And that's why it says the answer is the portfolio with a lower correlation between its 2 stocks. So this is another thing about logic. All you need to know is that the lower the correlation, the lower standard deviation you can achieve with the proper weighting of the portfolio. So we have a situation where 2 have the same expected returns. Well, whoever has a lower correlation between these 2 portfolios and their stocks, that one will achieve a lower standard deviation. That's it for this video. See you on the next one.